Hello, precious students. This is our last lesson of the school year, our last new lesson. So we are doing solving exponential and logarithmic equations. And those are just equations where we have logs and exponents, and the variable is in those places. So basically you need the same base for one way to solve them. So for number 1, the same base I can get from 9 and 27 is going to be 3. So I changed 9 to 3 squared and 27 to 3 cubed. Now using the rules of exponents, I multiply since they're outside of the parentheses. And now I can just set those exponents equal to each other since I have the same base and solve it like a regular equation. Can y'all believe this is the first thing we did in class, was just solving like two-step equations like that? Crazy. All right, so for number 2, I'm thinking 2 is going to be the base that I can get. So 2 squared is the same as 4, and then 2 to the power of -1 is the same as 1/2. Multiply your exponents, so it's going to turn into 2 to the 2x equals 2 to the -x plus 3, because you need to distribute that exponent to both. All right, and now I'm going to set the exponents equal to each other, get rid of the base, and solve for x. Beautiful. All right, for number 3, it looks like 10 is going to be the same base. So 10 squared is the same as 100, and 10 to the 3rd is the same as 1,000. Again, multiply your exponents. Once you have the same base, set just the exponents equal and solve for x. If you remember when we solved equations, you can do it in whatever order you want. And what I mean by that is you can either like subtract 2 from both sides first, or add 6 to both sides first, subtract 14x from both sides, but you should arrive at the same value of x no matter which way you do it. All right, for number 4, 3 is the same base that I can get. And I'm doing the same thing here on the worksheet that y'all have to complete with this. The problems are in order, just like on the notes, and so the first 4 should be ones like this where you can get equivalent bases, and then they go in order. So hopefully that is not too confusing. All right, I did the same thing here where I set the exponents equal to each other once I had the same base, and solved for x and got -6. Right, there are problems where you can't always have an equivalent base, so we're going to take a log of both sides. So this is going back to last lesson where we learned about logarithms. So I'm going to take a log base 4, since I have a 4 to the power of x there, of both sides. Right, this is another operation just like multiplying, or whatever. Log base 4 to the 4x is just going to be x. And then so that I can figure out what log base 411 is, I'm going to do the change of base formula so that I can stick it in my calculator and get 1.73. All right, so take log base 2 of both sides here. So you take log base whatever the number is with the exponent that has a variable. All right, so log base 2 of 2 to the x is just x. And then I'm going to do the change of base formula again to get a decimal answer. All right, log base 7 of 7 to the 9x equals log base 7 of 15. So 9x this time equals log base 7 of 15. Divide by 9. And I'll have to do the change of base formula again, and it's not too big of a deal. Log base 7 of 15 over 9 is log base 15 over log base 7, or not base 7, sorry, log of 7 divided by 9. And since we're not leaving it like this, you can just stick it in your calculator just like that. Log of 15 divided by log of 7 divided by 9. You end up getting 0.155.16. All right, for logarithmic equations, these have logs in them. So again, just like exponential equations, we need to have the same base for one way to solve it. And then you just set what's in parentheses equal to each other. As easy as pie, hopefully. Right, so those on number 8 have log base 5. So I'm just setting what's equal to, the parentheses equal to each other and solving for x. Alright, so x equals 4 on that first one. They both have the same base of 4, so I'm setting what's in parentheses equal to one another and solving for x. This works just the same for number 10, where we have a natural log, because a natural log has a base of e. So the bases are the same. And you just set them equal to each other and solve. Alrighty, this next bullet says if you're given an equation such as log base 4 of 5x minus 1 equals a number, you can exponentiate each side with a base of 4. So what that means is I'm going to make what's given to me an exponent with the same base as the logarithm. And then because of our rules from last class, 4 to the log base 4 of something is just going to equal what's in parentheses. Right, I think exponentiating is kind of silly when we know log rules that tell us that the base to the power of the answer equals what's in parentheses. So that would make much more sense in my mind. So that's what we're going to do for the other two. We are going to take 7 to the power of 2 equals 3x minus 2. So if y'all remember your your logarithm rules, this is what a log means. 7 to the power of 2 equals 3x minus 2. Right, this is instead of exponentiating both sides like we did in the first one. And then you just have to solve. So I think this method is much simpler when you don't have log base 2 equals log base 2 of something else. So for number 13, 2 to the 5th equals x minus 6. 2 times itself 5 times is going to give you 32 equals x minus 6. Add 6 to both sides and we have x equals 38. Alrighty, extraneous solutions should ring a bell. It's when we have a solution that actually doesn't work when you plug it back in. So y is the domain of a logarithmic function, not all real numbers. If I had something like log base 4 of x equals y, which means 4 to the y equals x, x is never going to be negative. No matter what you plug in for y, if you plug in a really, really small negative number, it's going to flip it and turn it into a fraction, but it's never going to give you a negative. Right? So I can't have log of a negative number. Right? So you'll see what that means when we check. But for now, for number 14, I'm using log rules. When you add, you multiply inside the parentheses. And remember, log by itself is a base of 10. So 10 to the 2 equals 2x times x minus 5. I am distributing that 2x to both terms. And this right here looks like a quadratic, if you remember what that means. It's when you have two answers because it's a parabola. So I'm going to subtract 100 from each side, and y'all should remember how to factor. We did it so much, but to make it a little easier, I'm going to divide everything by 2 so that I don't have to use that trick where I multiply and do all that crazy stuff. So now I need numbers that multiply to give me negative 50 and add to give me negative 5. So that is going to be x minus 10 and x plus 5. And then my answer is x equals 10 and x equals negative 5. So these are my two solutions that I'm going to check. I'm going to go ahead and check 10 first. I'm going to plug it back into the original. So log of 2 times 10 plus log of 10 minus 5 equals 2. This is log of 20 plus log of 5 equals 2. And then my logarithm rules tells me when I add two logs, I multiply. So log of 100 equals 2, and remember the base is 10, so 10 to the second, or 10 squared, is 100, so that one worked. Now this one, when I plug in negative 5, you can already guess that it's not going to work out. But here is why. When I plug in that negative 5 into the place of x, I end up with log of negative 10. 10 to the power of whatever will never equal negative 10. Right, so 10 is the base of a log like this. And it's just never going to happen. 10 to the power of negative infinity is still not going to give you negative 10. It's going to give you almost 0. So this one is extraneous. Alright, moving on to number 15. I'm going to use those same rules. When I add two logs, I multiply what the logs are in parentheses. So 5x times x minus 1 equals 2. And then base 10, so 10 squared equals 5x times x minus 1. And then just simplifying that, 10 squared is 100, like in number 14. And then distributing my 5x to both x and negative 1. This one, again, I can simplify so that I don't have my first number, the coefficient of x squared, being anything other than 1. I'm going to divide everything by 5 to make it a little easier to factor. So x squared minus x minus 20. So I need numbers that multiply to give me negative 20, add to give me negative 1, and that is going to be negative 5 and 4. X equals 5 and negative 4. You already guessed it. One of these is going to work and one of them isn't. But remember, that's not always the case. Sometimes they can both work. But in this case, this first one is going to be our winner. So log of 25 plus log of 4 equals 2. So log of 25 times 4, which is 100, equals 2. 10 squared equals 100. So that one worked out. Red flag. I have the log of a negative number. 10 to the power of something is never going to give me 20. It does not exist. So this one is extraneous. So my only answer is x equals 5. Alrighty, on to the last one, same routine. I am going to multiply x plus 12 and x By my log rules, I know 4 to the power of 3 is going to equal x plus 12 times x, which is x squared plus 12x. 4 cubed is 64. And now I am going to make this into a quadratic. Now I need numbers that are going to multiply to give me negative 64 and add to give me 12, a positive 12. So those are going to be a positive 16 and a negative 4. So x equals 4 and x equals negative 16. While I am checking the answers, I'm just plugging in 4 and then I'll plug in 16. I just want to tell you guys how much I miss you. I really, really hate that this school year ended this way, but I hope you all come to that parade that is on the 21st, next Thursday, because I want to see you so, so badly. This has really stunk not being able to see you guys every day. Y'all are such a joy to be with in real life. And you're a joy to be with in not real life as well, like over the computer. But I just love you all so much, and I hope you've enjoyed your time at home, but I know we are all ready for it to come to an end. So that's all I wanted to say. I love you guys so much. I hope you've enjoyed this year, and I hope next year will be even better. Bye, guys.